Very good afternoon. I welcome you all this 4-day post-lunch session. This is a lab and exercise. We had yesterday one lab and one exercise, and I'm very happy that most of you did it very nicely. Although the exercise was very lengthy, and half of you did not had any exposure to software and the data and all, but still you did it. So we thought that exercise may take longer even today, but most of you have finished. So last late night we sat together and then we prepared another. In fact, we prepared these two exercises, but we thought maybe we'll finish only one exercise. So since we have done it, so I'm happy that we are going to do the second exercise. Otherwise, we could have engaged some other activities, some other lab work or tutorial. So I think that since last 4.5 days, uh, about four days, we are getting very good exposure of theoretical aspects of various dimension of climate change, displacement, vulnerability, and many more things. Right? Uh, I feel that apart from theory, you have to have a exposure and understanding of the practical aspect. So that once you become a policy maker or you're working in an organization, that adds to your department and for the benefit of the state or whatever you say. So in this study, we had a climate change vulnerability uh, index we made. Now climate change vulnerability mapping we did it. Today, what we are going to make is flood vulnerability assessment. So yesterday we use AHP and we are using another advanced method. This is a bit more complicated, more time consuming. But since we have only today time for the demonstration and lab, we make it in a very simple way so that you can do it, right? So title exactly what we put it: flood vulnerability assessment using topo hydrological indices. Fuzzy analytical. It was yesterday. It was AHP. Now it is fuzzy. You know? So we all know what is fuzzy. Entire universe is a fuzzy. Yeah? You say something, you understand something. I say something, I understand something, and I say what I'm saying, what I'm understanding is the best one. You know? So it's all fuzziness. Entire universe is fuzziness. But within a fuzziness, there is something which is real and concrete. So one need to agree on aspect which is close to the nature and which is good for the human and animal life, whatever you say. So the method what we are using, the fuzzy AHP, and the first is this. There are three aspects. One is flood vulnerability, because floods what we are seeing today is again mainly attributed to climate change. Yesterday I showed you some slides on glaciers melt and on. The same is true for the entire world. So with that flood, climate change, what is happening? Flood is taking place across the world. Frequent flood. Flood is a natural phenomena, but it's a very frequent flood and devastating n number of people. And then the second issue is topo hydrological indices. Yesterday, what we took climatic indices. Those 6 indices we took mainly for temperature and precipitation. I showed yesterday the n number of indices you can choose as per your own need. But today, the different indices, that is topo-hydrologic indices, where the most of the indices are topographic, geographic, landform, right? Say slope, elevation, curvature, geomorphology, geology, and so and so. So these are the indices which plays an important role. There are two aspects. One is with the increasing temperature, snow and ice is melting, going to the river, flood is bound to happen, and then what is state of sphere on the surface of that. So therefore these are the topo hydrological indices. So let us go straight away to the steps, and I'm happy that yesterday you noted it down very nicely and understood the steps, and you did it. So these are the broad steps what we have. The first step, create flood conditioning factor as a raster layer. You must be knowing there are two layers, two broad layers. One is vector and second is raster. So vector layer is nothing but like a map. When you draw with a sketch, pen and pencil, that is a vector layer. which separate one entity with another entity. Whereas that is a discrete phenomenon. And raster layers are continuous phenomena, like satellite data. Each one cell has its unique value, right? If we have thousands and thousands of pixels, thousands and thousands, they have separate values. So it is a continuous feature. And we all know, I'll say a line or two on very childish thing, but which is very important. We know this line passer is what, this line passer is what, but computer do not know. Computer only knows 0 and 1, nothing else. So therefore, the lines and polygons what we have has to have converted into raster format. So therefore, what we have, conditioning factor as a raster layer, you need to create. How to create, from where the data source will come? I'll show you the data sources from where you can easily get it, free of cost, as I said did before. And then at the second step, reclassify these layers in ArcMap into 5 classes, 3 classes, 8 classes, normally odd classes, 5, 7, 9, 11, something like that. Now the question is when to create 7 class, when to create 3 class, right? I'm sorry. If the variation is more, if the variation in data is large and the extent and your study area is large, then you can go for more classes, 5, 7 or 9, 11. If the variation in data is less, then you can have lesser number. Ideally 5 classes is normally fair enough, right? Then after that, what you do is create a correlation matrix of flood conditioning factor obtaining weight through fuzzy HP. That is the most crucial and a typical step, right? Then at the fourth, apply a weight overlay in ArcMap. You apply a weight and you give weight, assign a weight in a way that has been given, designed and has been suggested by the expert committees, as we have studied also. And the last step, overlay the total then you get the flood vulnerability map, and then you need to see, you need to relate what all is going to happen if you have certain number of population in a particular area, right? So now this is the most important slide. Our most important slide is that from where to get the base, the data source. So if you see this one, there are 4 broad categories of this factors, topohierarchical factors. One is rainfall, second is DEM, SRTM DEM, synthetic shuttle radar topographic mission, and third is satellite data Sentinel-2B, and fourth is geomorphology. When you use the rainfall, yesterday what we did, graded data, quarter degree, 1 degree data is also there, right? So it's up to you, what data, if you want a finer resolution data, you can go for quarter degree. If you need coarser resolution, 1 degree, right? Rainfall data from 1st January 1994 to 31st December 2022, from where we get IMD. You click on that and you get that, right? You can increase the time period, you can have a lesser time period, but no less than 35, 40 years or so. The second, the data source, the topohydrological, the main base is SRTM DEM, which is a resolution of 30 meter by 30 meter. We know pixel is a square in shape. And what all we get? We get, using this DEM, we get slope, we get elevation, we get SPI, we get topographic wetness index, we get distance to river, we get drainage density, we get curvature, and we get convergence index. So you get 2, 4, 6, 8. This is 2014 data. Topography does not change much. It changed maybe in thousands of years. Slope change, yes, but not much. That again takes long period of time. It's a natural phenomenon. So this is 2014 data, and also because after 2014 SRTM data is not available. So we do not need. Even you see in earlier time what we used to have, topo sheet we used to have, and in topo sheet we have the contour in one, 20 meter, 40 meter or so, and we use it. And the topo sheet was surveyed way back in 1960s, 70s, Survey of India agency jo karti hai. From where we get this SRTM data? We get it USGS, United States Geological Survey, um, Earth Explorer. And the simple, you must be having account. Those who do not have account, to them, you go and create an account. What you do, like a Google or Yahoo Mail. Create an account. You select the satellite. You select the sensor. You select the date and time, and then download. And each data, this data is a TIFF data, single band data. There are two broad categories of data. We all know. Just to tell a line for the because it's a mixed group. Not only geography and geology and civil engineering, but other students also, other participants. We have one is pan data, single band data, and multispectral. Say pan data is a single data, same as the DEM data is a, you do not need to recognize any object. By seeing the tone, you can see what is the elevation, what we did yesterday, right? We'll show you here. Then Sentinel 2B data is a 10 meter by 10 meter resolution, very good data, better than Astra data. With this data, what we get? Land use, land cover, and vegetation cover. These are two primary important layers we use to create even today. We have n number of other parameters and indicators. We get it from NDVI. Say for example, I showed you the day we studied in my lecture. We get vegetation density, leaf cover index, and so and so. But the base layer is a normalized differential vegetation index. We took for April 2024. The Copernicus, this is a website. You get the download data free of cost, not a single penny. It's a European Space Agency data. You get two data from here, 8 data from here, and 1 rainfall. And then by using geomorphology data at a scale of 1:50,000, at a regional level, at a basin level, the scale is fair enough. Otherwise, you can go for 2,50,000 or so. 2024, April, September. From where we got it? Bhukosh. It's a agency and organization by Geological Survey of India, GSIA. And then what you do? See this one. Since this is the main source of data for most of them, more than half of the data layers, indices, what we do is step and download them. This is a site, Earth Explorer. I've already showed you. Download DEM TIFF or .img. There are two formats which image processing software supports. Either TIFF or IMG, right? ADAS imaging support, IMG and TIFF both, and many other. You get DEM TIFF, the final output. Last column you see, output file. Then there is another data that is ALOS, pulsar data. It's a better data, 20.5 meter. So if you are doing a micro level, it is ideal to have data which has a better resolution, that is 20.5 meter. But it was most recent data. Earlier we did not have. We had only SRTM data 120 meter. Then we have a better data of 90 meter. Then further development in sensor technology, we had a 60 meter, and then the 30 meter. Till very recently, we used to have a 30 meter data, but we have a better data. It's up to you. So you do not ask me which data is better. It is up to you to choose and to decide. It is you, I not. Depending upon the accuracy, depending upon the size, and many more things, right? Both are same. In step 2, load the DEM data. In ArcMap, I'll show there. This is the steps. Then we go for customized accession check specialist. We have done this. I'll not spend much time on that. These are the steps I'll demonstrate. I do not want to go in this. I'll show on the system, on the software. That will make you better understand. Then this is a data set and raster layer creation. Some of it I've already talked about it to you. From where you get, say for example, when you talk about this one, satellite data, sentinel data. This is sentinel copper indicators, and these are data types. You have a data of 10 meter, 20 meter, 30 meter, right? And output you get as a composite picture, composite image. And then you have the data in the toolbar, And then there is a very simple formula to, uh, using this data, Sentinel-2 data, 10 meter or 20 meter, 30 meter. Again, this is a spatial resolution. We all know there are 4 types of resolution: spatial, radiometric, and temporal. And so spatial resolution, again, you want to have 20 meter or 10 meter. Again, depends on the nature of work. What you want to have. With that, you get the line to line cover. And for that, there are n number of line to line classification models. And the most commonly used is supervisor and unsupervised. So you go for supervised classification, recode it, and finalize it. In the first go, by using the Sentinel data, you get the line to line cover. And then by using that same multispectral data, 4-band data or 3-band data, you can go for creation of NDVI in image processing software, in RGI software. It's a very simple step. No, there are different band. We subtract band, infrared band with a red band, divide with infrared band with a plus red band, right? Then you go on this, say for example, what is that? Individual band stacked is done. There is another issue which is there in that, okay, once you download any imagery, most of you must be knowing, but still I suppose half of you must not be knowing. When you go on a GLCF or USGS, you get the images band by band. Band 1, 2, 3, 4, 5, 6. And then you need to know which band makes a FCC or multispectral of that particular sensor. If you take Sentinel-2, it will have a different combination of bands. If you take Landsat 8 or Landsat 9, it will have a different set of band combination, right? So each band has to be downloaded TIFF one by one. Then in the software, the step process, we mosaic it, we layer stack it, so that you get the FCC. So this is what is written. I'll escape because of time. Then we calculate the NVI. This is a detail. Infrared minus band, red band upon infrared plus band. For Sentinel-2, it is band 8 and band 4. See here 4 and 5 and 4 here, but 8 and 4. Anyways, now then you calculate the NDWI, normalized differential water index. This is a formula. This is a band for which band? It's a very simple step. It will take you a couple of minutes. Then you drive the built-up index, many more things, right? Then I'll move on. This is from here the GIS work exercise starts. I'll show you in a minute. I have only a couple of slides. Then I'll jump to the software straight away, so that you can better understand. Yesterday I showed you add the data. You have added the data and this. Then you add the data of rainfall, elevation, the slope. These are the explanation of single line. You already know it. I do not want to read it. It's boring if you read a text, but sometimes you need to read it. And then curvature, that is influence of water, that is flow direction and concentration of water. Concave areas tend to collect more water and enhance the flooding. So you may be thinking why to need this data. So for that, it is a single line explaining the slope. Gentle slope favor the water accumulation. Where there is a steep slope, it will not accumulate water. Our objective is to model flooded areas, right? Then we have the drainage density, where we have the high drainage density. There are the chances of having more flood accumulation, because in the river is already water, and then that will spill out. Then we have another layer, distance to river. The closer to the river, obviously, the better chances of being exposed to flood. Then we have the convergence index. Convergence index is a new layer, which most of you must not be knowing. This indicates where water accumulates. The place where water accumulates much. We all know, obviously the flat area, in the flat area, the water will accumulate more. But if you move few meters from this place, even if you see with your naked eyes, that is a smooth, flat, but it is not flat. You drop a water, say half liter of water, and you see, even on this floor also, where start water flowing. So in that case, you need to know exactly where the water accumulates. For that, you need to have a convergence index, right? Then we have the NDVI, where we have dense vegetation. There is chances of less, flooding and all, because it promotes uh, uh, lesser flooding. Then steam power index, another important layer, which is erosive power of flowing water. Higher SPI values can indicate strong flow. Stream, this is stream power index. Erosive power, when the water flows, and if it flows at speed, if it's a volume, so it has a more chances of eroding something. So this is the a layer. Then we have the topographic wetness index. Higher the topographic wetness index, areas which will have a more likely chances of retaining water. Say for example, yesterday there was rain. The wet areas may retain water on the surface, but the dry areas, most of the water will be absorbed and will go down, and that may become the part of this groundwater. So therefore, this plays a negative role for them. Geomorphology geology is another very important issue that one need to terrains such as floodplain, valley, basin, inherited influence accumulates the water and flow paths. So geomorphology is also very important. Then a land use land cover. Say I was talking with one of the participant. If you go outside, we have the impervious surfaces. Highly pervious surfaces, you may not get much water logging. So that is another serious issue. Especially in the urban areas, not only urban areas, in the river valleys also, in the basin also. So these are the 12 layers we used. In fact, this is part of the work. This Intezar, who is sitting behind. So we took some of his, just to demonstrate you. This is the individual layer. I'll show you in a minute. This is a digital elevation model. This shows a height of 6534 meter and lowest is 287 meter. This is and you see the shade and you find where is this side we are closer to Himalaya, so therefore the height is more, right? So this is the layer what we have DEM, and this becomes a base layer for most of the spatial data layer, graphic layers. Now using DEM we got the slope, right? And this is a slope which has a low slope. This slope in percent. We calculate slope in two ways. One is percent, another is degree. We all know. So what we have, you can see the color shade, and then this we get the slope, and then from slope we get the topographic wetness index. Then again we use put it in a different color, use DEM. So DEM is the source for all these layers, and it takes hardly 2 minutes, a minute to create if you know the steps, right? So this is the topographic wetness. This is a water body. This is nothing to do with that. No, we need to look into this area. Then we have the convergence index. Again, we use the DEM. Then we have the curvature. Again, by using the DEM, we get the curvature map. Then we get the distance to the river. By using DEM, again, by using DEM, what we see, where are the rivers, where are the streams which is flowing, and it gives you an idea where all this, these are the rivers, that is the distance to river in a particular river basin again. And river basin flows where? In the low elevated area, and obviously water keeps going and then keep on flowing with the. So this is a distance to river map. Then we have a land use map data from Sentinel-2. You see, these are the different land use classes: water bodies, sparse vegetation, dense forest, built up, and barren. Now, I always say to all students that you need to follow a particular classification scheme, a standard classification scheme. And the standard classification, when you talk about, so we have the NRC standard classification scheme they have given. Like we have the Bureau of Indian Standard, we have the WHO standard, we have the other agency standard. Same is true with the land use classification. You cannot go as per your own wishes. There is another international standard, that is WGS, USGS standard. Then other scholars have made it different classification scheme, which is acceptable to the larger researchers. Land use map ban gaya hamara aapka, then you go for NDVI. Lower the values, lower the vegetation, higher the values, higher the vegetation. It varies between plus minus 1. Right? Then we have the stream power index, right? Again we use the DEM. Then we have the geomorphology map that we got it from Bhukosh Bhuvan. So from there, earlier what we used to do when we were doing research long back, so we need to depend on the topo sheets or geology maps. And from there we trace on a butter paper and we use it. Now you do not need to do that. And creation of data takes 90% of time. In fact, 95% of time, in some cases 98% of time. When you have created your data layers, be it a 10, 20, 40, whatever, the modeling, if you know you are expert enough in GIS or something, modeling takes 10% or 5% of time. Right. So therefore, what the Westward do that? We have the very large labor force. They ask to create a data layer, unless they do that. दिमाग वाला काम वो करते हैं और लेबरगिरी हम करते हैं, एशिया के लोग, है ना? आपने देखा जो हम देख रहे हैं आज, वी ड्राइव इन द कैब, तो कैब में ड्राइव करते सारा डेटा एक एक उसको उन्होंने आपसे बनवाया, बनवाने के बाद में, राइट? सो एनीवेज, सो व्हाट वी हैव, ये जियोमॉर्फोलॉजी मैप अब बना बनाया मिल जाता है, आपको कुछ नहीं करना है, रेडीमेड गेट डेटा यू गेट इट. And these are the geomorphology class: active floodplain, active quarry, dam and reservoir, and many more: river, piedmont slope, road cutting, and young alluvial plains and so and so. Right? इसमें हमें अपना दिमाग नहीं लगाना है. Software will take its own course. कि इसका क्या रोल है फ्लड में, इस जियोमॉर्फोलॉजी, इफ इट इज दिस क्लास इन अ पर्टिकुलर एरिया, इसका क्या रोल है, या क्या रोल होगा. The expert people have done it, and we need to get the output by creating data layer. Now, from here what we do is we navigate, we do that, we classify into 5 classes, because again we need to put on a certain uniform classification scheme. So as I said, कि 4 class बनाना, 5 बनाना है, 3 बनाना है, 7 बनाना, so we make 5 classes. Now for this study area, it was suitable to have 5 classes. So what we do is we go to special analysis tool, reclassify. Then we go and take this elevations here, TIFF, the data what we have done. So this is a TIFF elevation data that is displayed here. We take the value, reclassify class, and then we go for 5 classes. And then we give the output what we did yesterday, and we'll do it today also. So what we have, repeat the same process. Once you've created data, take one data every time and declassify into 5 classes, and then it will be a separate layer. So your original data will be remain as it is. वो कुछ चेंज नहीं होगा. सैटेलाइट डेटा था, आपने कोई चीज निकाला, SRTM से कोई चीज निकाला, वो दैट विल अगेन इट विल सेम एज इट इज. किसी को दे दो, 10 साल बाद भी यूज करो, डजंट मैटर. तो दिस इज व्हाट आई हैव रिटन हियर. Repeat the process for all 12 conditioning parameters. In your case, you may take 6, 8, 20, 25, whatever, right? So you have to do this, and we'll move in the lab. और आप सबको करना पड़ेगा, है ना? पहले का लेयर हमने बना रखा है, because we do not have much time कि हम आपको कहें कि साहब लैंड यूज बना दो, NDVI निकाल दो, तो लैंड यूज NDVI बनाने में 2 घंटा लग जाएगा, और बाकी की 12 लेयर बनाने के लिए एक वर्कशॉप और करनी पड़ेगी, 5 दिन का और. But we have my scholars have worked very hard. All of them are sitting. They are participants also. So in that way, I'm saying that at least you get to know. Once you learn here, you will provide all manual. Data is freely available. If you put it in front of you, the copies and steps, you can explore and you can do much better. No, and that is one of the most important objectives. क्लाइमेट चेंज वल्नरेबिलिटी, फ्लड की बात करो, डिजर्टिफिकेशन की बात करो, वो भी एक है. वी डिड वन वर्क ऑन नातूर, तो वो भी दैट वाज पब्लिश. एंड इफ यू डू दिस गुड स्टडी एंड मॉडलिंग एंड एनालिसिस, you can go for good publications also. Right? Now, so what it gives you, these are reclassified layer. What I said here ना, कि ये एलिवेशन हो गया रिक्लासिफाई को, जो ये दिस इज ओरिजिनल, जो यहाँ पे रिक्लासिफाई करके बाद आएगा जो डेटा, दैट इज डेटा इज हियर. सी, सो एलिवेशन, क्या कहते हैं, कन्वर्जेंस इंडेक्स, डिस्टेंस टू रिवर, कर्वेचर, डेंसिटी, ये सारे नीचे और छिपे हुए हैं. सो रिक्लासिफाइड लेयर, जस्ट आई एम शोइंग यू वन. और जितनी बार करोगे, एक चीज और चाइल्डिश में बताऊं, जितनी बार करोगे उतनी बार ये कलर बदलता जाएगा. आप कलर कॉन्शियस हो तो आप इसको कलर बदल दो जो आपका अच्छा लगे. ये एन नंबर ऑफ ड्रॉप डाउन में है ना. बट आई सजेस्ट दैट यू नीड टू फॉलो द साइंटिफिक प्रिंसिपल ऑफ यूजिंग एनी कलर कोड्स, कार्डियोग्राफिक प्रिंसिपल्स. उसके पीछे कुछ साइंस है ना. अपने कपड़े तो अपने हिसाब से खरीद लो, है ना, लेकिन आप जो है इसको फॉलो करो. दैट इज माई हम्बल एडवाइस. आप करो ना करो अलग बात है. देन स्टेप 3, अब ये थोड़ा सा मुश्किल एस्पेक्ट है. इसमें हम नहीं टाइम स्पेंड करेंगे और आपको भी नहीं कहेंगे इसमें टाइम स्पेंड करो. इसमें क्या करना है, बाय यूजिंग फजी, स्टेप 1, वेट, वी कैलकुलेट वेट ऑफ ईच पैरामीटर, कि कौन सा पैरामीटर कौन कितना भारी है. नेता होते हैं ना, बहुत भारी नेता होते हैं, बहुत बड़े होते हैं, जो कह देंगे पार्टी के लोग मानेंगे. तो ये जो आपके 12 लेयर हैं, तो 12 लेयर इज वन, ईच लेयर हैज सोन रोल. अब वो सभी इंपॉर्टेंट है, लेकिन कौन कितना इंपॉर्टेंट है वो हम बताएंगे या जो एक्सपर्ट बताए. बट दिस इज हियर द फजीनेस कम्स इनटू पिक्चर, कि आप वो जो अलग अलग आप रीड द लिटरेचर, पेपर पढ़ो, और रिसर्च करने के लिए ये कहा जाता है कि रीड मोर एंड मोर रिसर्च पेपर्स, सो दैट यू गेट ब्रॉडर अंडरस्टैंडिंग कि क्या चीजें हैं, किसने क्या किया, एंड हम इसमें क्या और नया करें, कुछ अच्छा करें, सो दैट यू गेट द बेटर रिजल्ट. व्हेन यू सेंड अ पेपर, तो वो ये कहता है कि आप कितना भी अच्छा करके भेजो, तो रिव्यूअर सेज कि वेयर इज अ नॉवेल्टी, व्हाट इज न्यू, देयर इज नथिंग न्यू टू इट. लेकिन हमारे लिए तो बहुत अच्छा नया दिखता है. वो क्यों दिखता है? दिस इज माई फॉल्ट, दिस इज नॉट हिज फॉल्ट. हमने इतने पेपर नहीं पढ़े, उसने पढ़ रखा है, तो हम तो कहते हैं इसमें ये नया है, बट आई डू नॉट नो, इसलिए आप लेस रेड. तो देयरफॉर रीडिंग लिटरेचर इज मोस्ट इंपॉर्टेंट, राइट. तो ये आप वेट असाइन करते हैं, यू नो, बेस्ड ऑन द एक्सपर्ट जजमेंट, राइट. तो इसमें अब ये देखो, एक तो ये मैं कह रहा था, दिस इज इंडिविजुअल लेयर का रोल. अब उस लेयर में से फॉर एग्जाम्पल इफ आई मेड 5 क्लासेस, अब उस 5 क्लासेस में कौन ज्यादा इंपॉर्टेंट रोल प्ले कर रहा है, इंपॉर्टेंट नेगेटिव रोल प्ले करता है वो फ्लड, ठीक है ना. तो उसको भी हमें देखना पड़ेगा. तो वन इज इंडिविजुअल लेयर एंड अनदर इज विद इन ईच लेयर द जो क्लासेस है वो क्या रोल प्ले करेंगे. से वेजिटेशन एनडीवीआई की बात करें, एनडीवीआई वैल्यू से 0.2 to 0.7, उसमें 5 क्लास कर दिया, तो 0.2 to 3 वाला ज्यादा प्ले करेगा नेगेटिव रोल, और या 0.7 वाला. सो नो, तो दैट इज व्हाट हम वेजिटेशन को बहुत ऐसे समझ पाए. जियोमॉर्फोलॉजी को हमें नहीं पता ठीक से, कर्वेचर को नहीं पता हमें ठीक से, बट दे नो, एंड देन अकॉर्डिंगली एज पर देयर, उनके लिटरेचर पढ़ने के बाद देन वी असाइन अ वेट. नाउ फजी इन AHP, the comparison matrix is constructed using expert judgment, what I was saying, to evaluate the relative importance of each pair of criteria using fuzzy numbers, typically triangular fuzzy number, TFN, right. ये करते हैं. then what we have, expert compare each pairs of factors, कि रेनफॉल का स्लोप से क्या रिलेशन होगा, स्लोप का वेजिटेशन से क्या रिलेशन होगा, स्लोप से जियोमॉर्फोलॉजी क्या रिलेशन होगा, 1 to 1 and 1 to many. तो ये बहुत मुश्किल काम है, बट दिस स्ट्रॉन्ग पावरफुल सॉफ्टवेयर एंड कंप्यूटर्स मेड इट पॉसिबल. यू डू इट इन से few minutes, राइट. सो विच वन इज इक्वली इंपॉर्टेंट, इसमें 3 चीजें आती हैं, इक्वली इंपॉर्टेंट, मॉडरेटली और मोर इंपॉर्टेंट, और एक्सट्रीमली और मोर इंपॉर्टेंट, विच आर देन ट्रांसलेटेड इनटू कॉरस्पॉन्डिंग ट्राइंगुलर फजी नंबर. फिर ये आता है, एक मैट्रिक्स बन के आता है, क्रिएशन ऑफ पेयर वाइज कंपैरिजन मैट्रिक्स। आपने देखा हो स्टैटिस्टिक में, से फॉर एग्जाम्पल स्लोप, स्लोप को स्लोप से लोगे तो इक्वली इंपॉर्टेंट है ना, है ना। आपके रिश्तेदार हैं तो वो भी बड़े अच्छे होंगे, हम भी बहुत अच्छे होंगे, है ना। वो करोड़पति हैं तो हम भी करोड़पति होंगे, है ना। तो इट हैज अ 1 to 1। लेकिन दूसरे से उसका इंपॉर्टेंस कम होगा। तो उसमें 3 चीज आती है, लोअर, मिडिल एंड अपर, लोअर बाउंड, मिडिल बाउंड एंड अपर बाउंड। सो मैं इसमें बहुत नहीं जाऊंगा बिकॉज बहुत स्ट्रॉन्ग स्टैटिस्टिक्स है, मेनी ऑफ थिंग्स आई डू नॉट नो ऑल्सो, बट आई नो हाउ टू डू इट, माई स्टूडेंट नो हाउ टू डू इट। तो उतनी ही बताऊंगे जितना आप, चूंकि बहुत सारे लोग नए हो। सो व्हाट वी गेट अ EHP एंड फजी EHP कंपैरिजन। जो हमने कल किया था वही है EHP। एक हर उसको लेयर को आपने उसका वेट दिया, दैट इज कॉल्ड सैटी स्केल। आपने पढ़ा होगा मैथमेटिक्स में, स्टडीज में। इसको 1 दिया, इसको 3 दिया। 1 जब देंगे इक्वली इंपॉर्टेंट, बराबर का है। 3 है मॉडरेटली इंपॉर्टेंट, 5 इज स्ट्रॉन्ग इंपॉर्टेंट, 7 देंगे वेरी स्ट्रॉन्ग इंपॉर्टेंस, 9 इज एक्सट्रीमली इंपॉर्टेंट। We cannot give 10 because there is nothing perfect in nature सिवाय भगवान एंड अल्लाह, है ना। हम कितनी भी अच्छी मॉडलिंग कर लें तो we get the accuracy of 9.9999 चलते चले जाओ, हजारों डेसिमल, तब भी नहीं अचीव कर सकते, बिकॉज इट्स यूनिवर्सली प्रूवन कि नेचर में कोई चीज़ परफेक्ट नहीं है सिवाय अल्लाह ने जो बना दिया। जिस हिसाब से सूरज की रोशनी आएगी, जिस हिसाब से जो चीज़ें हैं, हम आप कितना भी कर लें, बट वी कैन नॉट 100% एनीवेज, वी ट्राई टू रीच मैक्सिमम परफेक्शन। तो ये हमारा और रेसिप्रोकल है कि कुछ उसके उल्टा, मतलब यू डिवाइड वन विद अनदर एंड देन सी व्हाट इज। देन फजी EHP में क्या होगा, 1 1 1 2 3 1 4 5 6 and 8 9 1, and then reciprocal one upon another layer, then, and this is lower bound, middle bound and upper bound, right? Then we create a pairwise comparison matrix, right? जैसे हमने कहा 1 1 इसके पहले भी आया था, if we divide it by 3 it will come, 1 को 3 से डिवाइड करेंगे तो 0.33 आएगा, right? 2 से करेंगे तो 5 आएगा, और आपको 4 से करेंगे, 5 से करेंगे 2 आएगा, और 4 से करेंगे 0.25। we get this is done in the उसमें, और this is what we have in the next step. We create a pairwise comparison of matrix, and then in the next step we normalize the pairwise comparison of matrix, say C4 divided by C$16। this could be, यहाँ पे दिख नहीं रहा है, एक रो होगा एक कॉलम होगा, and once we click it you get certain value, so that value get translated here, right? For each parameter, for elevation, for slope, lower, middle, upper, for range density and so, right? Then we, in the step 4, for each criterion, each row calculate the geometric mean for normalization of lower, middle, upper, because normalization of data is the most important. ऐसा नहीं कि आप डेटा कुछ भी ले लो और उसको फिर आप करते चले जाओ, we need to normalize. I give one example, very simple, छोटा सा example दें कि data of say 100 rows, 100 columns, उसमें कुछ values हैं, चाहे एज का हो या सेक्स का हो या कोई डिजीज हो, इनकम हो, देयर आर सम एक्सट्रीम वैल्यूज, होता है नहीं, एंड एक्सट्रीम वैल्यूज गेट डिस्टर्ब द इंटायर रिजल्ट। सो वन नीड टू सी, एंड व्हाट वी डू इन अ सिंपल वे, वी ओमिट एक्सट्रीम वैल्यूज। एक्सट्रीम कुड बी इन अ लोअर बाउंड एंड एक्सट्रीम कुड बी अन अपर बाउंड। एक वैल्यू है से फॉर एग्जांपल 98, अब बाकी सारे वैल्यू हैं कितने पे, 20, 10 या 30, वो सारा पिक्चर खराब कर देगा, और बाकी सारे ऊपर है और कुछ नीचे है। तो व्हाट वी डू इज वेरी सिंपल, एक्सेल में भी करते हैं अदरवाइज, कि वी नॉर्मलाइज इट। और नॉर्मलाइजेशन और भी बहुत सारे तरीके हैं, दिस इज नॉट जस्ट वन, दिस इज वन आई एम गिविंग द एग्जांपल। ये ज़्यादा करते हैं, आई escape most of the statistics because we take the sum of all geometric mean, then we take reciprocal of total geometric mean one by one, and then we take the average of reciprocal in increasing order, Then we go for multiply each geometric mean to reciprocal. We get this step 8. Then we get defuzzification of the average values of lower bound, middle bound, and upper bound. We get this value. Make sure that sum of weight should be 1, otherwise we have to normalize this again. जितने होंगे सबका normalize करने के बाद obviously total should be, if we talking about something 100% होना चाहिए, कुछ values है, कुछ figure है, तो उसको 100 से ज़्यादा ना हो, 100 से कम ना हो. So I come on this the last part. What we have, multiply this weight by 100, because in our map it makes compatible, and then it has to be obviously 100% weight. Outcome, the resulting multiply normalized weight represent the relative importance of the each criterion, and that we use for the modeling of the different area. Now, so what we have done, you see this one, उसमें आप नहीं जाइएगा, उसको समझने के लिए you need time, कई दिन चाहिए, तो उसमें मत जाइएगा. I think we'll provide the Excel in the lab, और उसमें बहुत ज़्यादा मत जाइएगा, नहीं तो फिर उसी में टाइम निकल जाएगा. बट कुछ समझ लीजिएगा ब्रॉडर, है ना. कुछ हम लोग रहेंगे सब लैब में, जैसे कल सब हमारे मतलब टीम के लोग थे और स्कॉलर्स भी थे, हम सब लोग पीछे आपको जहाँ जिसको दुश्वारी थी बताते थे. तो इसमें अगर जो आप सोचे कि इसको समझ के आगे चले तभी होगा, तो फिर कुछ नहीं कर पाएंगे. इसको बाद में समझिएगा, है ना, तो ज़्यादा अच्छा रहेगा. देन व्हाट वी डू इज we go for reclassifying, and this is what we have: relative weight 1 2 3 4 5, right? And what we do is we go in this spatial analysis overlay and then weighted overlay. So what we did yesterday, we did fuzzy membership in the last exercise, and then we did fuzzy overlay. It was simple overlay, and this gives a result good, but this fuzzy HP gives better result. That is better, modeling. And above that, you want to have a better, analysis, better modeling. Then you go for machine learning and all. Then deep learning, AI का सब part है. Artificial intelligence में चले जाओ. Explainable AI में चले जाओ. That explains further कि what all the parameters, how they contribute, why that is not contributing. वो बहुत सारी चीजें, अब ऐसी टेक्निक, ऐसी चीजें आ गई तो wonderful. Anyways, तो इसमें हम जाते हैं, वेट ओवरले जाते हैं, करते हैं, एंड देन सी हियर, यहाँ पे जो सम इन्फ्लुएंस 100 आना चाहिए, राइट? यहाँ पे 100 आना चाहिए, जो हम कह रहे थे एवरेज आने का, राइट? एंड देन वी गेट द आउटपुट हियर, वी गेट द आउटपुट, एंड देन दिस इज अ क्लास वेट स्कीम फॉर दिस. व्हाट वी हैव हियर, व्हाट वी हैव, द टोपोग्राफिक weight percent is 10, slope has 12, density is 13. So if you analyze this column, what do you find? You find that the most important, criterion is drainage density, followed by slope. Slope होगा तो पानी निकल जाएगा, आपको कोई impact नहीं करा. Then we have the land use, and followed by main. Now, say for example, if we, then this is one for each layer. अगर 20 लेयर है, 25 लेयर है, 50 लेयर, तो सबका ऐसे निकलेगा, सबका ऐसे निकलेगा. रिलेटिव वेट ऑफ ईच पैरामीटर, कौन कितना इंपॉर्टेंट है. किसी फंक्शन में बहुत बड़ा आदमी होता है तो बहुत ऊपर बैठाया जाता है, बहुत अच्छे कुर्सी पर बैठाया जाता है, उसका हायरार्की होती है ना. तो उसी तरह से ये भी है, सब मिलके एक साथ काम करते हैं. व्हाट वी हैव, बट विद इन दैट, अब इसमें जो है क्लास 1 होगा तो इसको 1 ही साइन करेंगे, यहाँ 2 करेंगे, यहाँ 2 करेंगे, 4 करेंगे, उसको 5 करेंगे. ये जो मैट्रिक्स देख रहे थे उससे सारा निकल के आता है, राइट? नाउ व्हाट वी गेट द आउटपुट, वी गेट द आउटपुट व्हाट वी डिड यस्टरडे, ओवरले किया, फजी ओवरले किया जो पहले देखा था, एंड यू गेट दिस. एंड दिस इज द फ्लड ससेसिबिलिटी मैप, कि कहाँ ससेसिबिलिटी फ्लड की ज्यादा है या कहाँ कम है. Now see this one, जहां रेड पैचेस जो भी देख रहे हैं आप, वहां पे हाईएस्ट ससेसिबिलिटी होगी. एंड दिस इज द वेट लेयर, यू गेट दैट आउटपुट. एंड इन द लास्ट, द सेंसस मैप लिया आपने, डेटा लिया, वहां से पॉपुलेशन डेटा लिया, जो आपने कल किया था, सेम वी डू, वी अप्लाई ओवरले. कल हमने देखा था क्लाइमेट से कितने लोग इम्पैक्ट हो रहे हैं. नाउ व्हाट वी सी टुडे इन दिस एक्सरसाइज, दिस इज अगेन वेरी इंपॉर्टेंट, एक्सट्रीमली इंपॉर्टेंट, कि कितने लोग इम्पैक्ट हो. पॉपुलेशन तो वही रहेगा, बट इफ यू टेक 2024 डेटा, 21 डेटा, तो फिर उसमें सीनरियो बदल जाएगा. हो सकता है बहुत सारे लोग माइग्रेट हो गए होंगे. व्हाट एलेक्स वाज सेइंग, क्लाइमेट इंड्यूस माइग्रेशन, यहाँ से माइग्रेट हो गए चले गए. अच्छा, हिंदुस्तान में क्लाइमेट इंड्यूस माइग्रेशन कम है हमारा, है ना, बट पीपल आर वेरी सेंसिटिव इन द रेस्ट पार्ट ऑफ द वर्ल्ड. हमारे यहाँ वी आर ओनली सेंसिटिव टू मनी. लक्ष्मी जी, जहां पैसा ज्यादा मिले वहीं चल दो, भले ही हमारी जिंदगी 10 साल बाद खत्म हो जाए, ऊपर ना करे, बट पीपल, दैट इज, डिपेंड्स, that depends on individual, but we should be very sensitive to the nature, कि नेचर को हम प्रोटेक्ट करें, क्लाइमेट को प्रोटेक्ट करें. जो हमने कल दिखाया था आपको कि व्हाट वी हैव शोन, कि इंडिया पर्सपेक्टिव, इंडिया लॉट ऑफ मनी, $billion इज बीइंग स्पेंड, ताकि हमारी जनता ठीक रहे, स्वच्छ रहे, सही से रहे. सो दिस इज हाउ वी डू इट. सो यू कैन हैव पॉपुलेशन या कोई और चीज को देखो, यू कैन ओवरले, एंड देन दैट एंड्स हियर. नाउ this, in terms of presentation and writing part, I'll come to the software and then I'll demonstrate some of the layer, because if I keep demonstrating all the layer, we'll finish time here only. I feel that we should have a much time for hands-on practice, and yesterday I'm very happy that you did it till 6:30 and 7. Lab is open, जब तक आप कहोगे लैब खुला रहेगा, 7 बजे, 8 बजे, 9 बजे रात तक. If you finish it early, you can leave early. So we'll see here. We'll come to the software now. I'm sure कि बहुत सारे लोगों को आप सॉफ्टवेयर आ गया होगा, और जो अपने बहुत सारे लोगों के पास है भी. What is the folder, इंतजार? Where is the folder? This is one. हमें एक बार बता दो फिर हम. सी में जाओ पहले, दिस भी सी. अच्छा ठीक है, बस राइट. ओके, those who are in the back side may move forward, because the size is very small. The file name is small and the steps in the software is also small. So I request please move on so that you can have better. If you are fine sitting backside, you can read it fine. Okay, this is a dem data. This is a dem data. This is one scene, right? This is one scene. But my basin is something like zigzag. So I need to clip, right? जैसे हमने कल किया था वैसे इसको क्लिप कर सकते हैं. This is dem data. What we have, the high 1096 and this is lowest is 184, right? Dem data. अब इसको हम हटा देते हैं, and then we go to, just to show you, जब डाउनलोड करोगे सिंगल फाइल होगी और it will look like this. And wherever you click here, आप देखो, जब कैसे मैं पहले भी बताया था, if you take this icon I और आप यहाँ क्लिक करोगे तो what it shows, pixel value 730. That is elevation in meter, right? And if you click here on a darker pixel, this is 225. Value will be same, but if you invert करोगे तो ये brighter वाला dark हो जाएगा, dark वाला, but value will same, but only weaving will be change. उसको समझना, देखना ही बदलेगा, बाकी सारी चीजें वैल्यू नहीं चेंज होगी. Now let us go quickly. I remove this. I've showed this. Then sentinel data. कौन सा है अंदर इसके है क्या कहाँ पीछे जाओ ये वाला है ये वाला so you have not made FCC okay तो छोड़ो फिर कोई फायदा नहीं इसको दिखाने में we go straight away he is not make no the composite so anyways we take the dem data जो dem data क्रॉप किया था वो किसमें है dem data इसमें बेसिन वाला देखा होता एक ये में करा था एक जगह डाला एक में पर फोल्डर इसको बना के उसमें डाल एक फोल्डर दिखा बस बस ये चीज that's fine okay fine this is what I asked this is the base layer 12 layers what we have so what we have is here this is the elevation this is elevation we have clipped it to the basin extent then we have डेम पूरा नहीं जैसे स्लोप निकालने के लिए कहाँ डेम इसमें चलो so say for example this is a नहीं this is elevation है डेम वाला का है अच्छा चलो ये इसी को डेम नाम दिया ना fine See this is the dam Beas basin right इसके पहले जो दिखाया था हमने आपको वो दिखाया था then to create slope and aspect curvature everything what you need to do is you go to spatial analysis then go to surface right मैं वापस दिखाता हूँ एक बार go to ArcGIS tool इस तिजोरी में जाइए और तिजोरी में जाने के बाद फिर go to spatial analysis tool then go to स्पेशल एनालिसिस और इसमें स्पेशल स्टैटिस्टिकल भी है बहुत सारी चीजें ट्रैकिंग एनालिसिस है आप इफ आर वर्किंग ऑन ट्रांसपोर्ट इश्यूज ट्रांसपोर्ट प्लानिंग और सारी इसमें सो वी गो टू स्पेशल एनालिसिस टूल देन वी गो टू सरफेस वी वांट टू डू द सरफेस एनालिसिस व्हिच कवर्स स्लोप एलिवेशन कर्वेचर एंड ऑल सो देन वी गो टू स्लोप एंड आई टोल्ड यू वेयर यू सी द हैमर वो ऑपरेटिंग लेयर है डबल क्लिक यहाँ पे करना पड़ेगा you take the input layer this is a dem TIFF right then you give the output I made a test file so that I can delete it should mix with the other files हमने इस पे कहा slope 2.tiff do not forget to put the TIFF then this is all no change then say okay so model is running you see below blue color see this one we have not applied this operating layer mask and all otherwise and it has no value in fact it will give the some random values but it's not true value यहाँ पे क्लिक करेंगे तो इसका भी देखो 0 दिखा रहा है even if it gives a value तो इस तरीके से what we have got the slope then we get we can get what all we have curvature aspect we do not need here aspect is not that important that may be important for some other establishment and all curvature we need it curvature में हम जाते हैं and then curvature में हम ब्यास रिवर पे गए but वहां से भी जा सकते थे हम what we do then we give the aspect here sorry curvature dot TIFF right and nothing else I need to go to environment to mask and all I leave it because you already know it to save time ताकि हम quickly जा पाए lab में you have already understood this step. I hope it should come. It comes. Something went wrong. क्यों भाई? Something went wrong. We may do it again. कहाँ गया? Bias rem. We're already here. We go curvature. If the file, we take the slope. Curvature 2. Let's say put it 2. It comes. You know? Right? So same way what we have done, इसको हम हटा देते, मास्क कर देते, तो ये बेसिन का आउटर लेयर बाहर वाली चीजें नहीं आती. राइट? इस तरीके से हमें सारी चीजें बना लेने हैं. Basically you will get it in a lab. ये सारे लेयर you can make your own, right? Then after that uh, let me go to other layers. These are layers. Say land use map. This is land use map. What I've showed you. You'll use this. You're not going to make it. Then the other layer what we have is NDVI. This is the vegetation, layer. Then we have geomorphology map. We get it from that ready-made map. For NDVI, for this slope, curvature, you have to create by using the DEM. Then what we have is distance to river, right? The same map I've showed you in my presentation. After doing this, once you do it, I do not want to do all. I do not want to show it. You do it yourself in a lab. ये सब करने के बाद फिर रेनफॉल का है, वेटनेस इंडेक्स का है, सारे हैं. Then you go for reclassifying, right? We go to same spatial analysis tool. From ArcGIS toolbox, go to spatial analysis tool, and then go to reclassify, right? Then I'll remove these layers because there's no need to put all. I just put it to show you. Then go to reclassify, right? And reclassify, maybe I open it. ये इसमें सारे वो लेयर है ना, इसको ऐड कर ही लेते हैं. What you okay, fine, that will be good if you add the layers what you have created, right? So that it will be easier for density. Then we have elevation, then we have geomorphology, a land use class, and AVI. Then we have the slope, rainfall, okay. Now you go to, have you noted it down? Reclass, then you go to reclass, choose one layer, one by one, say I take topographic witness index, right? It will value, choose a value, and then you see, you say there are n number of classes here. You say classify, right? And then when you go to classify, go and check, select here 5 classes, right? Take this 5 class, and how it can be classified? There are different ways of classifying. Hmm. If I want to, make 5 groups of all participants, 6 or 7 participants, हम एज के हिसाब से कर सकते हैं, नंबर के हिसाब से, रीजन के हिसाब से, व्हाट हिट इट लाइक यहाँ पे स्टैटिस्टिकली व्हाट वी हैव मैन्युअली we can do it, equal interval can be done, define interval, quantile, natural break and many more. We use normally natural break, right? नेचुरल ब्रेक हम लेते हैं, स्टैंडर्ड डेविएशन भी है. इफ यू टेक स्टैंडर्ड डेविएशन तो ये कहेगा कि विच हाउ मच स्टैंडर्ड डेविएशन, हाफ, 1/3, 1/4, राइट? ये सारी चीजें हैं. सो एनीवेज आई डू नॉट वांट टू स्पेंड मच टाइम. इक्वल इंटरवल है, दिस इज व्हाट वी डिड. No, sorry, natural break, right? 5 classes, 5 class, okay. I say okay, and then I need to give a new file, new name. What is this? TWI, TWI, uh, underscore reclass dot if, yes, right? ये ले लिया, then say okay. Just 5 class ये आ गया. The same thing you have to do one by one. Sorry, reclassify. हम यहाँ से चले जाते हैं जियो प्रोसेसिंग से, and then results. यहाँ से जल्दी हो जाएगा मेरे ख्याल में. कहाँ आ गया? What is that? Current. This is reclassify, right? I select the layer, SPI, TWI हो गया, ठीक है, SPI, and do not forget to give underscore and then reclass. Sorry, है? SPI, right? Value हो गया, and then classify. We go 5 classes as we did before. What happened? कुछ गलत select हो गया, ठीक है ना? What? I'll go for that. अभी हमने क्लास दिया है. Then हम देंगे ये SPI underscore reclass dot tif. ठीक है साहब, कुछ छूट तो नहीं रहा? Please remind me if I make any mistake. ये SPI भी 5 क्लास में बन गया. Then we go next one. Input raster, rainfall, classify, 5 classes. This is a rainfall, rain, reclass dot tif, right? ठीक है साहब, everything is okay. This is rainfall. Slope. Sorry. Rain. Just slow. Sorry. Slope. Slope. Well, slope. Yes. Right. Then next, land use. LULC. Geomorphology. है क्या है? रिक्लास है, पहले किया था शायद. लेट अस डू इट अगेन. पता नहीं क्या है. आई डोंट नो. है क्या? हाँ वही. वी डू इट. नो इश्यू. वी डू इट. यस वी चेंज इट. राइट. Geomorphology. Right. Reclass 2. Elevation. This is elevation, na? Elevation. Density then. I make it DD, drainage density, short name. The second last layer, distance to river. D2R. One more. Right? Sorry. Curvature. One more layer. कितने खूबसूरत कलर आ रहे हैं देखिए, रंगोली से भी अच्छा. Sorry. CI. Okay. So all layer done. कोई छूटा तो नहीं? Now go to overlay and then get to fuzzy overlay. Sorry, weighted overlay, the fourth one. Then add each layer. Which layer? What we have created. नींद तो नहीं आ रही है लोगों को? हैं? आ रही है? नहीं, कम खाते हो तो नींद नहीं आती. हैं? चलिए कोई बात नहीं. अब इसके बाद नींद नहीं आई, लैब में जाएंगे when we start doing yourself. So we go to, मैं दोबारा दिखा देता हूँ, जल्दीबाजी में हम चले गए. The last part, we go to spatial analysis from arc toolbox. We go to overlay and then we go to weighted overlay because we have assigned the weight. Then add each layer from plus. ये plus जो है यहाँ पे, इसको plus करो and then इसमें इंतजार कहाँ जा रहे हो? देखो, देखते रहो, कोई गलत हम ना डाल दे. इन अंदिजा तुम भी देख लो. Anyone can see. Reclass only, है ना? This is a CI reclass, right? Okay. Then we need to add another one. Keep on adding one by one. Then we'll see. Then curvature, right? Add. Then you go and see the third one. Distance river. Okay. ये सारे लेयर यहाँ ऐड होते जाएंगे. Then क्या लिया हमने अब? DD ना? Next. DD. And then elevation, right? Geomorphology, yes. Elevation, yeah. NDVI, yes. And then slope, okay. Thus remind me, I may made mistake. अब के बाद नहीं, rain, huh? Then SPI. TWI. LULC कर दिया नहीं? हो गया? नहीं, sorry. तो I think we have done all TWI. CI हमने किया, अभी क्या बचा है? All done? Sure. यहाँ देख लेते हैं एक बार. 12 हो गए, ठीक है. अब यह देखिए सम टोटल, इट कम्स टू 100, है ना? है? हाँ, देन वी नीड टू गो टू, यहाँ पे देखिए आप, यहाँ पे देखिए, आई शो यू. कहाँ पीपीटी है? खुला हुआ है, यहाँ दिखा देते हैं. वैसे पीपीटी, हाँ, वेट है ये हाँ, यही लिख लो बैठ के. जस्ट नोट डाउन, यहाँ बैठ के तुम भी लिखो. नोट डाउन द वेट्स, या इसे फोटो ले लो, तुम लिखो. नहीं, एक बताएंगे, कोई फोटो ले लो या बताओ. सी, यहाँ पे जो वेट है, परसेंटेज वेट, जो दास आउटपुट व्हाट वी गॉट ना, जो मैंने पहले दिखाया था, TWI का 10 होगा, फोटो ले लो. एंड देन SPI, ये दैट वेट हैज टू बी ट्रांसलेटेड इन दिस द रिक्लासिफाइड मैप. अब हम यहाँ आते हैं, राइट. बताओ इंतजार. CI, इधर आओ. क्या तो लिख लिया ना? नहीं तो एक मिनट, इसकी इसका इसका फोटो ले लो ना. टेक द फोटो. तुम ले लिया तो इसे देख के बताओ. यहाँ पे, यहाँ आ जाओ. सिट एंड टेल मी. यहाँ के बैठ बताओ. वो आगे जाके लो. आ गया ना? अब यहाँ बैठो. He has taken a photo of this weight, then we'll put it here. TWCI. पहले CI ऊपर है. 7. Where is that? First inference. This will be 7. Manually do it. Then curvature. 5. आपने नोट किया, 10 क्रॉस चेक करते रहिए, कोई गलती ना. Then density to no D distance to river 11. Then come down. Then drainage density 13. Then you come down little. Then elevation का इतना बताइए. 11. Then geomorphology 6. Then land use 11. Then NDVI 4. Slope 11, 12. 12. Who said 11? मुझे भटका रहा तुम लोग. 2. SPI 8. TWI 10. Very good. Now it comes to 100, you see. So make sure it should not be less, it should not be more. ठीक है? And then evaluation scale 1 to 5. Then one more issue is that we have made 5 classes, right? तो ये गलती मत करिएगा, मैं भूल रहा था, अभी छूट जाता. It has to be 1 to 5, right? And then output. Then output. and then go home. Take output and go home. This is flood vulnerability, right? Dot if, yes. ये तो मुश्किल है. हम लोग वर्ड में फाइल में काम करते हैं, वो नाम दिया, क्लिक कर दिया, ओके, ना, राइट, ओके. आई होप इट शुड कम. तीन क्लास बनाया, तीन क्लास बनाया, तीन क्लास बनाया. It has make three classes. It should not come. Three classes. It should come straight away. Five. Let us see. Let us do it again. इसको कर देते हैं एक बार. हैं? यहीं से मिल जाएगा. We made some mistake. We'll reclassify in a minute. फाइव तो यहाँ दे दिया, आउटपुट जी सर. सर ये जो फील्ड की वैल्यू, अगर ऐसी कोई प्रॉब्लम आए तो हमें ये स्केल वैल्यू देखनी होती है, क्योंकि हमारी स्केल वैल्यू 3 तक ही है. नहीं तो कहाँ इसका इसका नहीं, इसका 3 है खाली. जिससे सब सारे 3 है. ये हम चेक कर रहे हैं, ये मॉडल देखा तो ये क्यों ऐसा किया इसमें, सेल तो नहीं किया. ये ऐसे कर देते हैं ना, चेक कर लेते हैं. देखिए जैसे ये जो मैंने देखा हुआ है, क्लास 1 2 3 4 5 को क्या देना, क्लास 1 को 1 तो दे दिया है, तो क्यों गलत कर दिया. ये सभी तो 1 2 3 5 है, कुछ कुछ में सर इसमें नहीं है ना, मॉडल में नहीं आया है, तो वही there is some minor mistake that no, if you go on this table, where is PPT, यहाँ पे जाते हैं तो देखिए क्लास 1 2 2 4 5, 3 नहीं है. इसमें जाइए तो 1 2 3 4 5, राइट, इन SPI में. And if you go here 1 2 3 4 5, right, so it has to be all 5. So therefore if I see here, that is a minor mistake that is done, you know, that has happened in a modeling. इसमें आप देखिए, इसमें तीन दो ही दिखा रहा है ना, यहाँ 3 हो गया, 1 2 2, you know, कहीं कुछ तो we need to go to scale value and then change, so it will come. That is not an issue, right? So I think we have done this almost 345 50. The smaller, you know, editing that has to be done to make it, you know, 5 classes. Uh, we can do it in a lab. So I do hope that you could understood. You have noted down, and do not worry if you have not written anything. We'll provide all these. Just give me a time today night or tomorrow morning. I'll upload all these step by step manuals. So if you know forget anywhere your, you know, manual or notepad, you'll get it from that. So thank you very much, and we'll move to the department. Finish this no, the conference hall exercise demonstration. We'll go to the lab and we'll have a tea there, and then we'll work on that. Okay, thank you.